Howdy, this is a video on how to run Homer2 scripts in the NIRS Toolbox. Basically, the NIRS Toolbox allows you to manipulate your data in just about any way you want to, and Homer2 allows quite the same functionality as well to many respects, but each one has its own limitations and advantages. What's pretty nice about the Toolbox, though, it actually allows you to use outside toolboxes. So if you want to use Homer2 in the NIRS Toolbox, you're welcome to do that. But it's not quite as straightforward as you initially expect, seeing that Homer2 offers built-in functions to be called in the command line or in a script in MATLAB. So does the NIRS Toolbox. The problem is the data format differs. When you load in a file into Homer2, it's in .NIRS format. When you load in a data set into the NIRS Toolbox, it actually creates its own data object, which differs in many ways. So what this is going to show, there we go, is how to actually call Homer2 functions without too much effort. You could potentially add in and reformat your data in a very long-winded manner in MATLAB in order to run Homer2, but of course that becomes time-consuming, relatively difficult, and is pretty prone to errors. So what Dr. Huppert did, which I think is very clever, is actually enable a module called Run Homer2. And this allows you to create Homer2 jobs or add Homer2 functions to your pipeline. The one thing that I highlight here is you can actually, when calling functions out of Homer2, most of the Homer2 functions will act on optical density and not raw data. So in many respects, and I won't go into detail on that, you're going to want to run these functions after you've converted the data to optical density from raw light intensity. So keep that in mind as you start calling these. So I think on the last slide, if you notice, here's the way you would actually create the Homer2 module to run Homer2. You'd call it as nirs.modules.runhomer2. And if you've seen any of the other NIRS Toolbox videos, you'll note that NIRS is merely a folder, modules is a subfolder, and run Homer2 would be the actual function. You call it empty, which would allow you to start your pipeline with this. If it's not starting your pipeline, you would have previous output from the previous module put into this function as the input. So here we're initializing our pipeline. We're outputting it as J. Within that, the Run Homer2 module actually has a function or FCN property, and that's where you would actually name the function. So the Run Homer2 module basically is allowing you to input any one of the Homer2 functions as a pipeline, but you have to actually designate which function you want to call. So here you would do that as saying j.fcn, which is the property in that module. You would name it as Homer2 whatever function it is. So this is just an example. Don't expect that this is the format here. I'll give an example in just a moment. So the user must select a valid Homer2 function name. So it actually has to be one of the names found in it. You can't have any spelling errors or anything like that. And also, you need, at least as far as I have found, you have to include the Homer2 folder in your file path. So make sure that you have the Homer2 downloaded. Make sure you include the folder that actually has each of the Homer2 functions in it. If you don't have the functions, the source code essentially, you may run into some trouble. I actually haven't tried it without the source code, so I would assume that the source code would be needed rather than the GUI. But make sure you have that already downloaded. Make sure that you have it added to your MATLAB file path. So I went through each of the function names just to give everyone a list of what functions are available. And also keep in mind that I haven't gone through each one of these exclusively. So there might be one or two that don't work with this function call. But I wanted to show on this video each function that is available. So you can screenshot this, flip through it, see something that might be of use for your pipeline. So you'll see each of the functions here, and actually as I go through, there's many. So anything from block averages to adding regressors to creating a GLM to filters to things, a wide range of options. Some of these are overlaps with the NIRS Toolbox. There's actually an equal function in the NIRS Toolbox. Some are unique. So this is one of the reasons why you'd want to call Homer2 in the NIRS Toolbox, is because some of these functions are not readily available. So we'll continue through. Again, if you see anything, you're welcome to screenshot, save it as a JPEG, and go through them yourselves. And I'm going to try to go through each of these over time. So you should have a video eventually of each of these. Okay, so that was each of the functions that you could actually potentially call. Also noting that when you call these functions, you're also going to have input parameters. So if I call, in this case, a PCA filter, I have to actually designate the input parameter for that PCA filter. In order to do that, you find the job that you designated, the run Homer2 module job, and you look up the VARS, which are the variables for that function. So parameters, variables, they're going to be the same vocabulary there. If you call j.vars, j.vars, vars, whatever you want to call it, you'll get the list of variables available. So in this case, it's NSV, and I designate that. This is essentially saying what percentage of variance do you want to remove with your PCA filter. Admittedly, I picked 0.86 kind of randomly, so don't imagine that that's the default you'll want to pick. But just to give you an example of how you would do it, I'd say j.run Homer2 or NIRS.modules.run Homer2 equals j. I'd say j.fcn. I'd select the PCA filter. I'd have to find the exact name, so I need to name it correctly, same capitalization, same spelling, everything. And then I'm going to figure out what the variables are. So you can either open the variable, it'll pop up and show you, or you'd say j.vars.nsv equals 0.86. Then you can run it. So to run it, just like any job or any pipeline in the NIRS Toolbox, there's a run method. So you can say j.run and select your data variable. In many cases, especially out of the demos that Dr. Huppert includes, raw is going to be your data. So you can just say j.run on raw. Again, keeping in mind that Homer2 will often want it on optical density. So at this point, you will have either wanted to include a conversion to optical density in your pipeline, or you'll have wanted to already convert your data to optical density. So you won't want it as raw voltage more than likely. If you have any problems arise when running it, the best thing that I've found is usually that has to do with a single subject. One subject has a different montage, a different number of conditions or tasks or something like that. So if problems arise, usually my way of going through it, I don't usually have large number of subjects, and usually each subject is me anyway. So I will go one by one through the subjects, or chunk them into subjects. So maybe I'll do the first half, and you'd call that just like a normal MATLAB. You'd say, if it's the first half, you say 1 to semicolon 10. So instead of having a 1 here, you'd have 1 colon 10. Here I'm running it on one subject. That just ensures that, okay, the function call is correct. It just has something to do with a subject. I can get an output. It will run cleanly. I don't get an error on this one subject. Use 2, 3, 4 until you run into that error and you can figure out who it is. Oftentimes it has to do something with the probe or something like that. And one of the subjects had a slightly different probe or missing a condition or something like that. If you guys have any issues with any of these particular functions, feel free to email me or send me a message on YouTube. I'm always looking for videos to do, and I have a list of ones that I'm going to get to out of my own curiosity, so I have my own priorities. But if you have any that are pertinent, please feel free to send me a message. Just a warning, my turnaround is very slow. I have a very full-time job, travel a lot, and I have a full family, so my free time is limited. But if it doesn't exist on that function, if it does exist, I'll forward you the link, and you can find it. You can probably find it on YouTube if you just search the function. If it doesn't exist, I'll work to make one. But again, keep in mind my turnaround may be several weeks to a month or two. However, I will work to make one. So bear with me. I'll have to study the function a bit and turn around and get the video going. Anyway, I hope this was helpful, and I hope it helps you. In particular, block averaging in the NIRS Toolbox now is incredibly simple because you can use the Homer2 block average function. I hope this helps your NIRS Toolbox learning. And if you have any more questions, please feel free to send me a message. Thank you.